today is the 12th September and it's exponential decay, this lesson. So first of all, if you could tell me what the questions from last lesson or yesterday, what was it? Was it solve equations? So, okay, go on, anyone? Am I right? Yes? Okay. So, if I recall, I said, right, this is still log, but it's a lateral log, which is to the base of the exponential exponent. What was the exponent value? 2 point E is equal to what? Yeah, 2.718, roughly. Yeah. If you don't know, then all you have to do is just go to your calculator, and then you go and type the shift here, yeah, and then just put a 1, and you should get your exponent value. Okay, so that's Euler number. Okay, so what did we kind of said? I think if I recall again, what bothers me was this denominator there. So we uses the law of ln if they are dividing. So let's say A over B, and that's the same as log A minus log B. Okay, so that's what we agree. Okay, so what I'm going to do now is going to decompose that, and I should now get log 3t equal to 2, and then I set big bracket, and then log 12 minus log t, and then add 2, and then very quickly, because we've gone through this, so expand the bracket, and then I'm going to then move all the t terms onto the left hand side. So what I do to this side, I'm going to add 2 log t. I must also add 2 log t as a balancing equations method. Okay, so therefore I should now have on this side just that, and then this is just pure number that you can put in a calculator. But I won't do that because there are still some number there, so it's not nice to have to work in decimal fractions. So we keep that there. Let's do something about here. So what did we agree on? So if some of you had a hint in the end, what would you do to this here? Yep. Yes. Now, if anyone just sort of, well, I told you I make a video, but the video will all just really focus on why we use log, because if you have 1000 equal to 10 to the power of x, I mean, you could guess this because you could have just done, 10 to the power of 1, that's 10. So it's not 1000, 10 to the power of 2 is 100. Oh, not 1000. And then eventually you will figure out x is 3. Okay? But how do we definitely able to work out x is 3 without having to do this trial? Because if I say to you, now this time, do this. What's x is now this time round? Okay? X is going to be a decimal number. I mean, no, you can't do that in your head. So there is no strategy in your GCSE syllabus that teach you how to solve x if x is a power. Okay? So that's why we are introducing log, because the log is to give you, so yeah, so it says if you have okay, sorry. So if you have a n log x, that is equal to log xn. By introducing log, we now know we can bring a power as a coefficient. How convenient would that be to solve problems like that one? So I could take log on both sides. Yeah. So this time round is doing the reverse. You know, for some reason I just have to bring that term back to the indices. So so going back then, using this law here, I just simply write log 3t plus log t square. Okay, so everything on the other side still remains the same. And we know if it's divide, it's take away. If it's adding, those two terms can be simplified by multiplying it. So log 3t times t square. So that's the part when some of you left, you sort of realize, okay, so this must be my next step. So can everyone appreciate that? Yeah. Okay. So that means now t times t squared becomes a single t, but with a cube. So now you just have one single letter now. So so log 3t cubed. So log 3t cubed is now equal to 2 log 12 plus 2. Okay. Now, obviously, my goal is to get t on its own. Okay. So what do I do now? This operation would not be allowed. Let me just think about this one. No, so what I'm saying to you now is, if you have log AB, you can't divide by log A. Isn't that okay? Isn't B okay? This is not an operation is allowed. So again, I said to you before, try some real numbers. If it works, then the rule applies. Okay, so yes, I will bring the 3 down. Okay, so I will bring the 3. So that's why I'm doing a lot more steps than I anticipate, because you might think this is really long, but actually you might have figured that out in your head, and then you might miss out these steps. So by bringing the 3 down, now I can divide everything by 3. Yeah, I divide everything by 3. So now that cancel out. So now I have log 3t is equal to 2 log 12 plus 2 all over 3, if you like. So, question is, how do I get rid of ln? What's the opposite of ln? Your calculator gives you a hint. It's always the button above it. Yeah. So, yes, is e to the power of, and they're deliberately doing these questions to introduce that. So basically, the opposite of ln is to take exponential. So if I make a note here, take exponential on both sides of the equations. And so what you have got is you have E L N 3T. That's how you write it, by the way, if you take that. And then you will have E and then everything in this index here. And guess what? Ln and E, they cancel out. So that leaves you with 3t. Okay, because they are the opposite. So if you like, in the future, if you're going to take exponential on a ln function, you just write 3t. But I'm just writing it the correct way a mathematician would have done. Okay, so and then the same. Yeah. So so I just do a dot here. Okay, and so now I can throw the 3 to the other side. So what you would have in the final answer is 3t is equal to 3 to the power of e, and then all that. And then that's what you put in the calculator, and that's your answer to that. Okay? Sorry, what am I saying? It's divided by 3. It's divided by 3. Yeah, all over 3. Yeah, all over 3. Sorry. Yeah, so it's 3 times, so you divide by 3. Yeah, so just plug all that in a calculator. If you could do that. Yeah, so it would be 3. Yeah, so what you're saying, if this was t over 3, yeah? So yeah, you times by 3. Yeah, 3e to the power of that. Yeah, because you're timesing 3 on both sides. Okay? Now, because you asked me that question, I'm going to ask you a question in return. But what if is this? What if? Let's do it on the, let's take the top bit off. So this is a GCSE question. This tells me if that pupil is a grade 9 or not. But it's a very simple one. What if is this? What would you do now? Three is at the top. Common answer is that they times 3 on both sides. Yeah. Now you just asked me the question, what if t over 3? Yeah. So, and I said to get rid of the 3, you times 3. Yeah. So you cancel that out. But what if the 3 is at the top? What would you do? Oh, that's fantastic. Yes, exactly. So just reiterate. Well, all I have to do is flip this upside down to turn it back to t over 3. But what do I do to flip this upside down? It's reciprocal, which means the power is going to turn into negative. Yeah, so it's 1 over. Basically, I'm going to do 1 over that as a positive. 1 over 2 to the cube is 2 to the minus 3. So 1 over e to the something is e to the minus x. So that's why I just simply have to put a minus sign in front. Okay, that's it. So don't think you have to. You can't really get rid of the 3 like that. You have to flip that. Okay, so there we are. That's all I want to talk about on the log. I think now you would know more at this stage than probably what the exam is asking you. Okay, I think it's a little bit simpler in the exam, but it's nice to know this because this course is about preparing you for university or apprenticeship. So you may face a much harder problem. So at least you have some skill there. Okay. Okay. So now on to exponential decay. So what I would like to do, first of all, I'm going to introduce a little website which is really good. So it's called desmos.com. Now, has anyone used it? Oh, good. That means you had a good maths teacher. He was alright. Okay. So again, if you want to make a note somewhere, it's called desmos.com, because your calculator that you have doesn't plot graphs. Okay, that's good. But yeah, you will have to have it if you're going to do A-level maths, because otherwise you'll be disadvantaged. Okay. Yes, I think if the maths department can get them very cheap, so don't go out there and buy it for £99. I think they sell it for like £20 or £30. Oh, even free. Oh, even better. Yeah. Oh, I think they loan it out and then you have to return it. That's good. Yeah. Anyway, is it a colored one? Okay. All right. Good. Okay. Right. Anyway, if you haven't got it, this is as good as the calculator version. So basically, I introduced this, from year 7 when I deliver maths, etc. Because if you want to see, what happened if you have a gradient of 2, you can visualize it. And then I will say to the pupil, when I have y equal to x, it looks like this. So then they can appreciate that whatever that coefficients in front of x gets bigger, the line gets steeper. Okay? So then they, hopefully, if I'm teaching top set, I will have more curiosity coming out and say, sir, how can you generate a non-straight line? How can you change the equation to be a non-straight line? Can anyone suggest? Yeah, do a power. So sticking to the same equations that I've got, the power is shift 6, so to get that, and square, you get a smiley curve. Yeah. And then they say, so how do you flip it upside down? Can anyone remember how to flip the curve so that it's a sad? Yeah, so negative index will give you a sad curve. Yeah, unhappy. Oh, well, that one does it. So, oh, yeah. No, it was minus in the coefficient, sorry. Minus in the coefficient, that's it. So the gradient is a negative gradient. Okay. So now today we are talking about exponential decay. So exponential decay involve also growth as well. If you don't mind, can you also write in the title exponential decay, which you wrote, and growth. Okay, and growth. Just add that for me, please. So let's start with y equal to 3 to the power of, no, so let's go for 1 to the power of x. Yeah, there we are. Okay. A simple straight line. Okay. But then if I go 1 equal to 2 to the power of x, is not a straight line. Okay, now this is an exponential growth. Now watch again. What if I do y equal to 3 to the power of x? Would the growth be more or less? Even more. Okay, so if you're going to do business study economics, that's very basic because they don't want to touch too much maths, but that's the thing. This is at least you will have to talk about in economics and business studies about exponential growth. Okay, so so you can see an exponential. This is basically an exponential function, whatever power of. But sir, you might ask, but you said exponential is the letter E. What did I say letter E equal to? Yes, so what I do is I put y equal to 2.718, which is the e to the power of x, which is going to be in the middle of this one and this one. Okay, now guess what? Let's get rid of that one, and that one. And just put, let's see if the software understand my e. Okay, oh, it does. So there we are, overlap. Okay, so what I would like you now to do is in your exercise book, can you sketch the y equal to ex, and I would like you to label it so that you can also go and say y is a ax or 2.718 to the power of x as well. And also just to do a quick sketch of y equal to 2 to the power of x and y equal to 3 to the power of x. Just to show yourself that as the exponent, that the base is getting bigger, the growth becomes more steeper. Okay, so write in your own words what you see in that behavior. Okay, so unlike A-level maths, we don't have to explore in details how exponent comes about. You have to study about Euler's number. Okay, we don't. We just apply it. Okay, so basically sketch three curves. you know, one one is less steep, if you like, and then the other two is steeper, but the one which is 2.718 to the power of x should be in the middle. Well, not middle, but it should be closer to the 3.3 to the power of x1. You can see the pink curve is nearer to the purple one than the green, because it's not 2.5, is it? It's 2.718. So that's exponential growth. So whenever you see any engineering application devices has an exponential has a behavior like that, has this curve, when you plot the graph, you can call that an exponential function. And then once you've done that, have a think what happened when the index x becomes a negative. Okay. So can you see the green here? The green color button here. It tells you what color curve this belongs to. Is it the reflection? Sorry, you wanted to see 2 to the power of x. Yeah. So exponential functions has the form of something to the power of x. X has to be in the index. All right. Now that's why the beauty of this is if I start showing this to year 7, if they're keen, then if they're inspired, they will play with the letter and then identify what would happen. Well, you can just plug that in and then you can see what it will happen instead of waiting for the teacher to tell you. So 30 years ago when I did maths lesson, we didn't have that. Every time when we have a question and wonder what it would be, we have to plot it ourselves, and that takes a long time, and it put us off. But now you can do this instantly. Okay, so I said, have a think what happened if the index becomes a minus. So I'm going to straight away and then put the minus in front of x. There you are. Okay, so once again, please plot that quickly in your just sketch. You don't need to do this accurately. Okay. But look where they all meet. Where do they all meet? Okay, that's a grade 4 or grade 5 GCSE answer. Well, a higher level, you're not wrong. It does meet at y-axis somewhere. They all meet at 1. Why? Why do they all meet at 1? No. What's 5 to the power of 1? What's 5 to the power of 1? 6 to the power of 1. Okay, so what you're trying to say is anything to the power of 0 is 1. Exactly. So this is when x is 0, so everything is 0, 0, 0. Well, minus 0 is 0, yeah? So anything to the power of 0 is 1. That's why they all meet there. Okay? So if you, so just give a minute or so. So you feel free to play around with the program. Okay. And and make sure you make some notations. This is where taking notes is important, and this is you simulating a university environment. That remember, in university the lecturer only tell you things. They don't stay behind and answer questions. They leave faster than you get out. Okay, so they are lecturer, they're not teachers. Okay, they only are paid to tell you. Well, they do it on a PowerPoint. That's it. Okay, you don't get it, you go to the library and you figure this out. Okay, so that's why some people quit after 1 year. They think I'm not paying £9,000 for this. Okay, but that's what university is all about, because you are an independent learner now. Okay, but but don't get me put off. But you are going to be taught by some really well-known people. So, I would rather do that. Yeah. Oh no, some very well-known professor, because they are so well-known, they get paid by some very low-ranked university a lot more money to come and change the place. So you might find some really, well, they usually look like Einstein. Their hair is all fluffy. Yeah, where if it's in engineering, computer science, they are chubby people. Okay, because they sit a lot with Coca-Cola. Okay, it's true. It's true. Yeah. Hmm? Yeah. Yes. Yeah. But sometimes I think it's overrated. Um, I mean, the thing is, don't get me wrong, but one should aim for Cambridge. Yeah, I know. I taught a pupil. He got um, um, well, grade 9 in GCSE, and then he studied history and stuff like that. And then he was aiming for A, and he was so not confident, he didn't apply for Cambridge. But in the end, he did get those A's. He would have got in. But yeah, so you got to believe in yourself. Um, if Cambridge you can't get in, then you can think about other places. But I didn't go to either of those, Imperial or Cambridge. I went to Canterbury, and that was that was a remarkable university as well. So I don't think you have to choose the best 10. But anyway, going back to this, what I want to say here is I want to focus on this one first. Now, yesterday I mentioned about the battery. Okay, I want to show you how I play around with this curve. So all I'm going to do is I'm going to delete those two, and I'm just going to put E there. Okay, and because in a moment the books want me to mention this. Now, obviously, I'm talking about time. So I'm talking about a battery that you're going to use. So imagine I just charge my phone 100%. I take the phone out, so it's now at maximum. So right now, I start the clock at time t when it's 0. And then I'm going to use it throughout the day. So anything beyond the minus sign, I don't care about it, because it doesn't exist. It doesn't have negative time. So from 0, the battery is fully charged. And it does follow exactly this behavior. It's an exponential decay, the battery. Okay, you will find that the battery drains really quickly, and then it has about 40% left for a long time. But that 40% is not enough sometimes to power certain things. So that's why they have to automatically turn it off. So when you see your phone saying that in 10 seconds it's going to switch it off, it's because battery should not be completely drained. The mechanism, the chemical in there should never be like completely discharged. If it's completely discharged, your battery is finished. It cannot be charged again. It's the phenomenon of battery, and that's why many people go and study battery in university, because this is where our problem is. Our technology at the moment doesn't allow us to. We can only use 60% of a battery. Okay, we have to leave that last 40% there. Okay, so yeah. Now, my question is, my phone that last time I read was 5.5 volt, the battery. When it's fully charged, when I put a voltmeter in, it should read 5.5 volt. Now, look at the curve. At the moment, it's at 1. But at maximum, at 0, time at 0, it should be 5.5. So what do I do to change this graph so that this point is now at 5.5, which should intersect there? What do you think I need to do to this equation? Yes. Okay, thank you. So therefore, I just listen to you exactly, and I go plus 4. Okay. All right. He meet one of the goal because column he managed to get 5 volt. I want 5.5 volt. And secondly, the discharge, battery discharge towards 0, right? But you've brought the whole line. This seems to merge towards 4. Now there's a name to this, okay? So this here is called an asymptote. Okay, now you heard it from me, A-level students, because this is, you're going to spend at least 2 weeks just on asymptote. So I'm going to write that on the board for you. So just together then, we're going to just quickly sketch one. So let's put let's just do an XY axis. Oh, sorry. And then I'm going to do this just randomly. Okay. Now, and then what I would like you to do is do a dotted line. Now I'm doing it freehand. Hopefully you got a ruler. If not, actually we can't do that at the moment. We have to wait for 2 weeks before you can touch my equipment. Now, what looks like the curve is about to touch, that line, this line is known as the asymptote. Okay, asymptote. So where I just, when we go back to the decimals.com, you'll find my asymptote is when y equal to 4. Okay, so in that software, I will show you again, y equal to 4. Okay, so that's something to bear that in mind. So so not quite right, because it didn't merge with my 5.5 volt. So possibly you might say, right, let's add 4.5 instead. But my asymptote should merge towards 0 because I'm discharging my battery towards 0. So let's just save time. I'm just going to review this to you now. So if you do 4.5, no good, because it's just bringing that asymptote there. So the battery should behave downwards all the way, looking like the asymptote is going towards 0. Thank you. Yes, is the coefficient. So put 5.5 there. That's it. Okay. So, and let's go back to the, let's take some notes then. So, the general formula for this is A e minus to the power of minus x. Okay? Whereas A is where the line going to touch. Okay? Actually, let's put a can you just help me just denote A naught instead? Just put A naught. Okay? Okay, so next thing, I want you to make a note of is battery acts like a discharging capacitor. and it capacitor, it has a discharge characteristics as follow, and it's written as A equal to A naught e to the power of minus t over RC. So if we make a note, this is a discharge of a capacitor. And these are voltage. So this is the maximum voltage, and this one is the voltage at time t. Now don't write this down. Okay, so what it will look like is this. Let's use that. Let's go with red. No, that one. So let's say the battery or capacitor has this characteristics. Then no matter what, that's called A naught. Why is it called A naught? Because when t is 0, 0 divided by anything is also 0. E to the power of naught is 1. 1 times A naught. So when t is 0, 1 times A naught is A naught. A is always A naught. Yeah? Okay. I'm going to that in a moment. Okay? So at time t, no matter what, is at the, that's why it's called maximum voltage, because A naught is when it's fully charged. RC is that it's to make a capacitor discharge, you must form a R and resistor and capacitor. It's arrangement with a resistor and a capacitor. Okay, without it, it doesn't discharge, because it wants to discharge because someone wants the charge, and the resistor wants it. If without the resistor, the capacitor is just going to hold the charge. So just let me, I'm just going to give you a capacitor to look at. So this is what a capacitor looks like. Okay. Have you noticed there's one is a longer leg and one is a shorter leg? Because one leg longer is a positive, one is a negative. Okay? You will be using the capacitor a lot. So that can hold charge? Yes. It tells you how many farad. It holds, I believe, is that 100 microfarad? Yeah, is it 1 mu? 1 microfarad then. Yeah. So it holds very, very little. Okay? To charge your phone, you probably need 1 million of this. Okay? So, but we'll come to that because we're going to look at charge as well. So when you for example, if you turn something off, like I don't know if you have any equipment at home, that when you turn the power switch off, the light's still on for about maybe a second or 2 seconds. That's the sign of capacitor in your circuit is slowly discharging out. Okay, so that's one way of knowing what's inside that box, and inside there are probably lots of capacitors. Okay, so and if anything, if the circuit doesn't work, most likely I would say 8 out of 10 that circuit has a blown capacitor. Okay, so that's what I would look at if I'm going to fix someone's electronics. It's most likely a capacitors got blown out. Okay, not the fuse. Okay, so what then? Yeah, so now you got RC. So the choice of the resistor and the capacitor, I mean, don't worry about it. It's just our resistance value times capacitance value. It just gives you a number, right? Now, let's explore that with decimals and see what happens if I have a different denominator. What happened to my curve? Okay, so I'm going to have to put RC there, right? So I'm going to put, let's say, let's do 1. I'm copying that, and I'm going to add, and I'm going to change the denominator to 5, and I'm going to change the denominator to 10. Look at that. So if I want my battery to discharge slowly, all I have to do is get a capacitor value and a resistance value that are large. Either way, times together, the bigger the denominator, the slower that is going to discharge. Okay, so that's the characteristics of that. And can you make a note now in your notebook? This RC is called the time constant. This will be in your exam. So if you know it, you will think, wow, that's easy. The question will be saying, they give you this whole equation, right? With RC equal to number, and just say to you for 1 mark, time constant for this equation is what? 10. If the denominator is 10, that's it. Okay, but if you didn't know this, you would think, where's the time constant? There's no t. So everyone would write that because it's got a t in it. So they thought time constant must mean the t means the time. Okay. The t, which is now to summarize up, is that what if I want to know how much of my battery is still holding charge at what time? Because this is my time on my x-axis, right? So if I want to say, oh, after 3 seconds, what's the time of my what voltage is my capacitor or battery? You plug that into here, put 3 in there, and then RC is already a number. A0, you know how much you charge it to. So if my power supply, my battery or my phone is 5.5, that will be 5.5. So now you have all the numbers. Then you can work out what that is. But your answer is always going to be smaller than, yes, because you're discharging. Yeah. Okay. Now, if you would be my A-level students, physics student, I would have asked you for your homework, what would the charging of a capacitor equations looks like? Okay. Okay. Call me Chinese, but what do you mean by opposite? What do I do? I have an equation, and you're telling me that is opposite of that. So tell me, what would opposite to this equation be? But first of all, most commonly people do say the word opposite a lot. So if I go A equal to A0, can you now tell me what is the equation for a charging then? A equal to, well, you say opposite, so it says a quick way you could tell me what's the opposite. Okay. Uh, okay. Can you read out the equation then? Okay. It's just the whole word is A naught. So we are not mixing up with the A here and the A here. Okay. E. Oh, power RC over T. Okay, fine. Okay, good. So I'm gonna plug that in with my graph. So let's delete this one. So basically, all you have done is just flip my fractions, yeah? Okay, but I still keep the minus, isn't it? Is there a minus or no minus? No minus. Okay, fine. So I copy that, and then I'm going to put 10 there and x there, and then delete the plus. Now, as I'm doing this, you could see my graph happening. Divide by x. There you are. It went there. It went to a negative zone, which can't be. So, but there's a. So, I mean, Dylan, what can I do to change that? Well, if let me put back a negative. That looks about right. That's almost like, because charging means going up, right? So I'm happy kind of that, but it's not hitting a 5.5 volt, is it? So there's still something wrong with this. Okay. So until next time. Okay. Thank you for coming today. Thank you. Yes, if you just leave it on the desk, I'll pick the capacitors up in a moment. Yeah, just leave them there. I'll touch.